So we managed to create our buttons in Figma, and as you can see we have two different buttons. They are built differently. One of them is built using paddings, and as you can see we have our hug property set to our width and height. Basically, hug property allows us to dynamically resize the button. However, the other one, if we take a look at the right hand side, we have set the values to fixed on width and height, which is not recommended. When it comes to buttons, you should dynamically let them grow and use padding to adjust the values. So how do we get this button exactly the same size? Here, as we can see, we have 8 pixels of padding on left and right side and 4 pixels of padding on top and bottom. So if we visit our Visual Studio Code, we have a class of sign up, which is attached to this sign up button. We are already giving it the correct color and background color. All we need to do is to give it the correct padding size. So there is two ways in CSS for you to give your elements spacing. So we use padding to give our elements inner spacing, and we use margin to give our space outer spacing. And the way it works is, if we have a background color, we can use padding to increase the size of our button, and if we have two buttons next to each other, we can use the margin to add space between two buttons. And as you can see, the naming convention is again with dash, no spacing. So if you decide to use padding top, you have to write padding dash top, all lowercase. Same rules apply with the margin as well. So if I go back, as you can see, we have our button here. If I try to zoom in a little bit, the first button has the padding left and right of 8 and the top and bottom of right. So how do we do that in Visual Studio Code? So what we can do is write padding top 8 pixels and then also write padding bottom, and then I press return on my keyboard, and as you can see it auto creates that for me. If I go back again to Figma, padding left and right is 8 pixels, top and bottom is 4 pixels. So here we have these as 4 pixels each. There we go. And now we need to just give it padding right side, which is 8 pixels. And if you want to duplicate, you can hold Command and D. Make sure to have your key bindings. Again, you can search for the command duplicate selection. I already explained in the previous parts of the video how you can customize your keyboard shortcuts. Mine is set to Command and D. And as you can see, I duplicated this line and I just changed the value to left, and then I have that as 8 pixels. So I'm going to save this. And as you can see, once I save this, if I take a look at the right hand side, the sign up button is, tiny bit bigger. What I can do is also in Chrome, try to zoom in a little bit so we can see the difference, because if I don't zoom in, I'm like at 300% right now. You see, because I gave it a padding of 8 pixels on right and left, we have a bit of a spacing added to left and right. However, you see the entire button is taking all the available space. And why that is the reason. If I go back to my button on Figma, you see it doesn't take all the available space. It's actually set to hug and hug. In Visual Studio Code or in general and web development, we don't have a property called hug. We don't have any of this. However, we have a property called width. Also, we have a property called height. So as you can see in CSS, we have the ability to give our HTML elements width. In this example, you see that we have lots of different values: VW, which is viewport, percentage, EM, rem. We can get into these later on, but what we care about is giving the pixel value. But if we do give our buttons a pixel value, they are going to be fixed, and we don't want that behavior. We can apply that logic if we do decide to have our button exactly the same size. Here you see, if I click on this drop down, our value is set to 89 pixel in width, and then also 43 pixels in height, and this is actually a fixed pixel value. There is no padding that has an effect. Again, if I click on the padding and I just make it 96 pixels, you see we have 0 effect on the width and height of this button. So the paddings are 0, and this button is actually being controlled using width and height properties. So here I'll just give it 100 pixels of width, and let's just give it 50 pixels of height. So for my login, the way I can control it is I can go to my login CSS declaration, and I can give it the width and then press return on my keyboard and give it 100 px, which is 100 pixels. And now I can create another line break, give it a height, and give it 50 pixels of height. So I can save that. And as you can see, it actually controlled the width of my button and also the height of my button. And my button no longer goes all the available space. So it only takes the 100 pixels that I defined it, and also the 50 pixels of height that I gave it in the login class. However, what you notice is in the web development, the text is not aligned properly, even though we gave it the correct width and height. If I go back to Figma, here you see the actual text button is center aligned. We don't have that behavior when it comes to web development, so we have to give it a property called display. If I go ahead and click on my button and switch to dev mode, here you see this button. Once I click on it, if I go ahead and zoom in, here we see that we have a display called flex. And also flex has some properties which is called justify content and align items. By giving these values to my button, I'm able to center align my login text inside my container. So what I would do is I would go back again to the design mode. Now I want to introduce another property in CSS which is called display, and display has multiple values. One of the values is flex. So we were able to see that value if I go back to Figma and then try to toggle that. Here you see we have a value of flex and basically a property of display. This is exactly the same CSS properties that we use in front-end development. And the way flex item works, you can think of this dotted line as basically a flex container or a button. So if you have, again, multiple items, it really doesn't matter if you have a single text item or multiple text item. As soon as you add a display of flex to the parent container, you have the ability to align your children item on the cross axes and also the main axes. So in this example, we have our button, and as you can see, we only have one children. Here, if I click and I basically duplicate, you see I have the ability to have multiple flex children. I don't have a use case of having two text values in a button. You usually have one text value, so I'm going to delete that. But you might have an icon or something in your button along with the text. So this is where you would use flex as well, to align your icon with the text inside your flex container. So the way you initialize a flex container is by giving it the property of display. And as soon as you give it the property of display, you're able to choose a value of flex. And as you can see, the default behavior is set to align left. In this example, we have justify dash content, which is set to the default value of flex start. That basically means as soon as you have a display of flex, all your flex children item are aligned to the left. So if I go ahead and try basically adding a display of flex to my login button, as you can see, we have my login button and we already gave it a fixed height and width. All I need to do right now is to give it a display, and then I press return on my keyboard. And here you see we have a list of values to choose from. What I'm interested in is the flex, so I'm going to select display flex, and as soon as I save this, you see nothing happens. And the reason is, by default, all the flex items, which is in this example, this text children item, is aligned to the left. So if I go back to this slide, you see the default value is always set to flex start on the justify content, and it's always aligned to the left side. So how do we center align it? We use a property called justify content, as I mentioned previously, and we gave it the value of center. Justify content property only works if you actually enable flex when it comes to your children elements. So if you don't give your HTML parent element, in this example, our button, a display of flex, you're not able to use justify content. Justify content only works when you initialize display flex, and once you do that, you'd be able to align your items on the main axis using the justify content property. So now if I go back here again on the Visual Studio Code, I already gave it a display of flex, so my login is a flex item. And if I go back to Figma, here you see we have the ability to center align our item. On the right hand side, it's center aligned, and this is how we control the alignment on the Figma. So by default, it's always aligned to the left and top. This is the current behavior of the Visual Studio Code. So the way we would center align this login is in Figma by basically clicking on this icon. So here we would center align this. So if I go back to Visual Studio Code, all I need to do is just write justify content and then give it a value of center and then save this. And right now you see that my login is now center aligned on the button. So if I go back to one of our slides, here you see justify content only works on the main axes. When you have flex items, you have two axes, one which is the cross axes and the other one is the main axis. So if you decide to center align something on the cross axis, you have to use another property, and that property is align items. Again, by default, align item is set to flex start, which means your flex children element is always aligned to the top. So if you decide to center align it, all you have to do is give it align items of center, and your flex children items would be aligned to the center. So if I go back to Figma, here you see we aligned our login text to the top, and if we want to click the center alignment, now our text not only is aligned on the main axis, it's actually aligned on the cross axis too. And this happens when you combine justify content with align items. Even if I try to toggle the dev mode, click on my button, here you see on the right hand side we have justify content combined with align items. So all I have to do in Visual Studio Code right now is to go to my login and add another property which is called align items. I press return on my keyboard, give it the value of center, and then right now you see it's aligned to the top. As soon as I save this, my login is aligned to the center right now. But what you notice is if we decide to use this approach, if I have login basically with us at the moment, like something like that, and I try to save this, here you see your basically text gets wrapped. And the reason your text gets wrapped is because you gave your login item a fixed value of 100 pixel. Your button is not dynamically growing the same way it grows in Figma. This is true if I go ahead and try to copy everything. Now I navigated back to Figma. So if I switch back to the design mode and I double click and I try to paste this, you see it overflows and it doesn't act the same way as it does in the front end. The reason is your login is actually set to dynamic value. So in Figma, if you go ahead and set it to fill, as I set it to fill, you see right now my login exactly acts the same way as my front end code. So if I go back again, here you see our text is being wrapped because we're adding a width, and the children item only take the available space, they don't overflow. But what if we want our sign up to dynamically grow as we type our text values? So if I go back to my button, here you see we have again 8 pixels and 4 pixels added to left and top and bottom, which is great. And now we take a look at the property. The width is set to hug, the height is set to hug. However, we don't have these properties on the front end, but we already know we have a property called display, and also we have another value called inline-flex. So if I go back and switch to dev mode, here if I click on it, right now you see that we are setting our display to inline-flex, because by default in the web development world, we have certain HTML elements that take all the available space by default. So you have to override that value with the property of display. So if I go back to my Visual Studio Code, all I have to do is just give it a display, and instead of flex, here you see we have a value of flex. All I have to do is just write inline-flex, and as soon as I select that and save this, right now you see my sign up exactly has 4 pixels of padding top and bottom and 8 pixels of padding on left and right. And not only that, if I go ahead and try to copy this text, sign up with us at the moment, and I try to save this, you see our button grows exactly the same way it does in Figma when you have the hug value. So if I go back to Figma, you see here on the width side, we have the hug value. So if I go ahead and try to double click and paste the value, you see your button grows exactly the same way dynamically. So these are the main difference between dynamically making your elements grow or giving it a fixed value, both in Figma and when it comes to your front end development. Always the recommended approach is going with this to making sure your buttons grow dynamically. However, when it comes to certain elements in your pages, usually the mobile size, you don't want your buttons to dynamically grow. So on mobile devices, you usually want your buttons to take all of the available space. So this is where you would override the width behavior and ignore the paddings that you give to your elements. Moreover, if you have to give your elements padding in all directions, you don't usually give them padding top, padding right, bottom, and left one by one. You have a way to give all of these properties, padding top, right, bottom, and left, in one single property, and that is called the padding shorthand. This goes exactly the same way for the margin. So if I go ahead and go to the next slide, right now you see we are no longer giving it padding dash top or any of the values. We're simply writing the padding property. And if we do write the padding property and just write 10 pixels, that would be applied to all the directions. So in here, you see we have all these values. If I go ahead and remove all of them and just give it a padding value and just give it, for example, 20 pixels and save this, you see 20 pixels is now being applied in all directions. So how do I apply things to the top and bottom left and right without actually defining each of them one by one. All I have to do is to give them a shorthand version. So if your padding only has two values with a space, here we have our property padding and we give it a value of 10 pixels, and then we add a space and we give it another value of 5 pixels. This would automatically tell CSS to apply 10 pixels at top and bottom and apply 5 pixels to left and right. So if I go again to Visual Studio Code, if I do decide to have 20 pixels added to top and bottom and only like 8 pixels to left and right, all I have to do is just add a space and just write 8 pixels. And if I save this, right now you see that top and bottom has 20 pixels, which is wider, and left and right has less space. So we're adding left and right padding of 8 pixels. And if I decide to individually write this, I can use the clockwise direction. Clockwise direction means if you write your first value with a space followed by your second, the way it works is your first value is always going to be the top. So in this example, we're giving it a margin. Margin and padding exactly works the same way when it comes to the clockwise direction, which means if I decide to give my padding 10 pixels and a space, that would be applied to the top. And then if I do 20 pixels as my second, that would be applied to the right side. And if I do 8 pixels as my third value, that would be applied to the bottom. And if I finally do another 5 pixels, that will be applied to the left. So there's 3 ways for you to add margin and paddings to your element. One, which is giving it one value, which is applied to all direction. The other one is giving it 2 values. The first one is applied to the top and bottom. The second one is applied to the left and right. And the other one is to apply this with 4 values, which works with top, right, and then bottom and left. Or you can simply give your elements a padding dash top or padding dash right if you want to be more explicit. So if I go back to my buttons here, if I try to add more values, now if I go ahead and add 60 pixels and also, for example, 12 pixels, right now 20 pixels is applied to the top side, 8 pixels is applied to the right, and now you see 60 pixels is applied to the bottom. So what you notice is as soon as I save this sign up button is going to have a 60 pixels of padding at the bottom and then 12 pixels of padding to the left. So if I save this, right now this is the padding that I gave to my button. Usually you don't want that kind of behavior. I just wanted to showcase there is a shorthand way for you to write your paddings. Simply, if you decide to have a shorthand, you can do that. If I go back to Figma, if I click on my element, I have 8 left and right, 4 top and bottom. So what I can do is simply write 8 pixels, which is top, and then 8 pixels, which is bottom, and then finally 4 pixels left, 4 pixels right. Again, it would be top, right, bottom, and left. If I save this, now my button is back to its normal shape. Also, if you have a repeated behavior, which means you have 8 pixels top and bottom with the same value and left and right with the same value, you can simply omit all of this and only have 2 values, which means 8 pixels would be applied to the top and bottom and 4 pixels would be applied to the left and right. So if I save this, nothing will happen. It's exactly going to have the same result. Now we know how we can dynamically make our buttons grow, or we can override this behavior and making them wrap to the next line.